Okay, second step after we label the nodes voltages, we need to label the currents. Okay. Now, as I mentioned today in the class, when you assign the currents, if you have a parallel elements or branches, always assume the current going down. And I will explain to you why. And then from left to right. Okay, so let's give, this is I1, this is I2, I3, and I4. Ah, okay. I3. Okay. So this is step number 2. Step 1, label the nodal voltages V1 and V2 if they are not labeled yet. Step number 2, label the current directions, parallel elements or parallel resistance from top to bottom, horizontal resistance from left to right. Again, you could do the other way if you want. But the reason that for the assuming the current going up to the bottom, because when you apply the KCL and then you apply Ohm's law, so in this case, I1 would be V1 minus 0 over 10. So assume that you forget about the 0, so it's fine. It will be V1 over 10. You are not going to have any problem. But if you assume current I1 going from bottom to top, and you forget to write 0 and then minus V1, then it will be V1 over 10, which is similar to this one. And in this case, will give you a wrong answer, wrong solution. Okay, so that's why, because again, here, if you get the 0, it's fine, no problem. But here, if you don't start with the 0, then you will forget about the negative side. So this is one thing that you need to pay attention to. And this is why I always tell the students, try to assume current going from top to bottom. Okay, step number 3, apply KCL at node V1 and V2. Now, again, if you want to do write down the equations of all the currents in terms of voltages, you could do that, make them ready before you apply KCL. So I1 is equal to V1 minus 0 over 10, and then I2 will be V1 over 5, and then I3 will be V1 minus V2 over let me move the I1 here. Okay, V1 minus V2 over 2. So there's a slow response when I write down. So that's V1. So again, always when you write down, when you apply Ohm's law for the currents, always start from the tail. For I3 will be V1 minus V2, not V2 not minus V1 over the 2. Same thing for I2, same thing for I1, V1 minus 0. V1 minus 0 over 5, V1 minus 0 over 10. And then the last one will be I4. So I4 will be V2 minus 0 over 4. Okay, do you see everything? Do you see my writing on the?
Yeah.
on the green and the gray side. Okay, good. Again, this is optional for you if you want to. The reason that sometimes I might, even the book, they don't ask you to find, for example, what is the current through the 5 ohms or through the, which is, the question will be finding V1 and V2 and find current through the, I will label like I10 ohms. Okay, because I don't want to give you the labeling. You are free to label the currents as you wish. You call it I1, I2, I3, whatever you want to call it. So I will ask you to find, okay, what is I10 ohms? What is I5 ohms? And so on. And then other question, what is the power consumed by the 10 ohms? What is the power consumed by the 2 ohms? Okay, so this could be the question will be asked in the exam beside finding V1, because when we do analysis, doesn't mean that we just find the nodal voltages. It means that we need to find all the currents in each branch, voltage across each resistor, and the power consumed by each resistor. Now, for example, if I ask you to find, the power through the 2 amps, there's 2 ways to find it. You could use I. Now, which I pick? I3. Okay, you have to look to the current that passes through that particular resistance. You square it, multiply by 2 ohm. If you want to use the formula for V square over R, then the voltage across the 2 ohms will be V1 minus V2. It's not V1 by itself. Okay, it's V1 minus V2 of square. That will be the voltage divided by the resistance 2 ohms. So these are the 2 methods we use to find the power. But again, it's easier to use the I square R rather than using V square over R. So when you use V square, you have to pay attention to which V we're talking about. The V will be across the 2 ohm resistance, or the V across the 5 ohm resistance. The voltage across the 5 ohm resistance will be V1 minus 0. So it's V1. But the voltage across 2 ohms resistance is the difference between V1 minus V2. Okay. So continuing on applying the KCL, so again, I advise you to start with writing all the currents, all the branch. These are called branch currents. It's not a loop. When we deal with the mesh analysis, we call the mesh currents. And when we deal with the nodal analysis, we call this is a branch current, which is the branches, which is for the 2 ohm, 4 ohm, 5 ohm, and 10 ohm. So if we apply again KCL at node 1, node V1, and node V2. Okay, so we go to node 1. So we see that I1, I2, and I3 are leaving the node. So we add them up all, and then equals the current leaving the node, which is basically 6 amps. Okay, so again, the I1 is leaving here, I2 is leaving 6, sorry, yeah. Oh, wait a minute, all of them are leaving, correct, sorry. It's my mistake here. So this will be a plus 6 equal to 0. So there's no current entering the node, according to our assumption that I1, I2, and I3 are leaving. Now, sometimes, as I said, some people, they like to assume all currents entering, like here, like here, like here. It's fine. But again, you have to be careful when you determine the current. This current here will be 0 minus. So that's why usually I don't care whether the current you assume is entering or leaving. I care about current in a parallel branches from top to bottom, horizontal branches from left to right, whether they will be entering the node or leaving the node. This is not a problem. Okay, so after we write down the KCL, then we come to the next one by applying the currents or using Ohm's law for I1, I2, I3, and so on. So it will be V1 over 10 plus I2 is, again, you could look to the circuit or you could look to your definition that you wrote it down here, will be V1 over 5 plus I3, which is V1 minus V2 over 2 plus or equal to 6 minus 6. Okay, so that would be, as I said, do not use a fraction. The other thing, I want you to show your work when you solve for V1 and V2. So do not use your calculator, because I know there's some calculators that you insert the coefficients of the variable, and then you plug it in the calculator, and the calculator will give you V1 and V2. I don't want you to do that. I want you to learn how to solve the problem. Okay. Everybody wrote what I wrote. I mean, I want to erase. So let me, if you need more time to write down. So we need to find, again, addition to this problem, we need to find I10, I5, and P10 and P2. And again, you could add as many as you want. Okay. So you could have a complete analysis to the to the circuit, which complete analysis mean knowing all the voltages across each branch, all the current through each branch, all the power consumed by all branches. Okay, so I'm going to erase the whole page and then start writing the equation one more time. Okay, so again, the equation would be, the first equation will be V1 over 10 plus V1 over 5 plus V1 minus V2 over 2 plus V2 over 4 equal to minus 6. Again, we want to get rid of the denominator, so we need to multiply by 20. Again, I don't want anything down. I don't need anything in the denominator of each of these terms. So 20 divided by 10 is 2, so 2V1, and 20 divided by 5 is 4, so 4V1. 20 divided by 2 is 10, so 10 times V1 is 10 V1 minus, again, 10 V2 plus 20 over 4 is 5, so it will be 5 V2 equal to negative 120. Okay, collect all the similar terms. So we have 4V1, we have 10V1, and we have 2V1. So that will be 16 V1 and negative, and then we have 5 V2 and negative 10 V2. So it will be minus 5 V2. So minus 10 plus 5 is minus 5 equals to negative 120. Okay. We box this equation, and this will be our first equation. Okay. Any questions so far? I mean, every step we do here when we work on another problem will be the same thing. Okay, same steps. Just follow the steps. Assign the nodal voltages if they are not. Assign current directions. Apply KCL, and then multiply by a factor, whatever that common factor will be. Which, when you pick that power, the common factor, when you divide by all of these numbers, you left with, no fraction or number. Okay.
I have a question.
Sure, go ahead.
Where did the V2 over 4 come from?
The V2, which V2? Over 4?
Yeah.
I was
Where,
gonna say the same thing.
where it's coming from?
Yeah.
Yeah.
From here? Oh, wait a minute. Wait. You are right. I mean, I don't know why I put a V2 here. You're right, because I'm looking down here, which is this will be for, thank you for catching this here. So you're right, there's no V2 now. The V2 will be used, V2 over 4 will be used when we apply KCL at node V2. Thank you for catching this. Okay, so let the correction here. So that one will be moved away. Sorry, this one. Okay, so it will be negative 10 V2 equal to 120, correct? Okay, so we have 2V1 wait a minute. Yeah, 4V1 plus 10V1 minus 10V2 equal to negative 120. So we have, this is will stay, the V2 will become negative 10. Okay, and we could simplify the equation by dividing by 2. So 8V1 minus 5V2 equals to negative 60. Now, in this situation, we will label this as equation 1. Okay, so there's no need to give another number for, so this will be our equation. You could keep it this way, you could leave it. Okay, now we move to node number 2, and we do the same steps, applying KCL, and then converting I's into V's by apply Ohm's law. Okay, so 2 steps we need to do. So we have 6 coming in. Again, let's put this one here, I3, I4, and the 3. Okay, the 3 also entering the node. The I3 also is entering the node. So remember, this current here is a flow until it hits the node. That one, the same thing, the 6 is going to enter the node. The 3 is going to enter the node. I4 is leaving the node. Okay, so that will be, it's up to you to move the numbers one side and variable in one side, minus 9. Okay, this is 9, so I move it to here, and I4, I move it to, becomes an, what do I do? Yeah, anyway, so let me do it the other way. Maybe people that don't like the minus sign with the 9. Okay, so I keep the 9 here, and they move the I3 to the other side with the I4, so it will be I4 minus I3. Okay, then we apply Ohm's law. So I4 will be V2 minus 0 over 4 minus I3. Again, we already had it before, the equation V1 minus V2. Again, you could look to the circuit and figure out what is I3 in terms of V1 and V2, equal to 9. Okay. Then we multiply by the common factor, which is 4. So that one will be V2. Let's see, V2 minus 2V1. Okay, so 4 over 4 is 1. 1 times V2 is V2. And then 4 divided by 2 is 2. 2 times V1 is minus V1. And then remember here, you have to be careful here. So negative times negative become a plus. and then 2 times V1 is 2V2, so equal to 36. Okay, so I'm going to write down the first equation, and then the second equation, I want to collect the similar terms. So we have 2V2 and V2. This will be 3, but I need to rearrange. Always put V1 first, plus 3V2 equals to 36. Okay, so again, these are the two equations I want to solve. Okay, so again, elimination, sometimes it's easy. So if you multiply equation 2 by 4 to match the 8, and then we add, so we say, multiply equation 2 by 4. And so it will be negative 8V1 plus 12V2 equal to, so this will be 24, and this will be 144. Okay, so 4 times 6 is 24, 4 times 3 is 12, plus 2 is 14. Now again, we could divide this by 2. Well, we need to add it anyway, so we add. If you want to name this as equation 3, then you said add equation 1 plus equation 3. Okay, so 8V1, negative 8V1 will cancel out, and we have a negative 5 plus 12 will be 7V2 equal to, so we subtract 144 minus, so 4 minus 0 is 4, 4 minus 14 minus is 84. Okay, then V2 we divide by 7. So this would be V2. Now to find V1, we could use either equation 1 or equation 2 and substitute for V2 to determine V1. Okay. As I mentioned, when you do this homework problem or you study for, for the exam, always do the details as I do here and write down the steps. When you do that and you come to review, then you know exactly what happened. You know why. I mean, if you put something without mentioning what you did, for example, if you don't say multiply equation 2 by 4 and you wrote down the final answer, then you might say, okay, what happened? Why I did this step? And so you keep, reminding yourself of what that step is about. But if you write down a statement like apply KCL, apply KVL, apply Ohm's law, so this statement, engineers usually they don't like to write too much. But again, just one sentence, apply KCL at node A or node B or node V1. It's not a long statement to write, and it's going to benefit you when you come to review. Okay, so again, I could put a statement here, use or plug. If you call this is equation 4, always use the numbers to refer to. Plug equation 4 into equation 1 or 2. Well, I mean, you don't have to do this one, so let's say, but when you write it down, that means either one will do the job. Okay, equation 1 to what? To solve for what? To solve for V1. Okay, and then start plugging So you need to plug for 8 V1 minus 5, and then plug 84 over 7 equals to minus 60. Okay, and then use your calculator and then find V1. Okay, so let's show you also what I meant when you use the matrix method. It might be easier or clear to follow, or those steps, they are so nice. Even you don't need to write down a lot of information. So let me see those. If I try to erase this one, it take a long time to do that. I don't want to waste time here. Just I want to keep the two equations. Maybe I will bring a piece of paper and a pen and write those equations and then erase everything at once. Okay, so what I need here, I need equation 1 and equation 2, and I need a delta first. So I write down all the coefficient minus from the left-hand side. 8 minus 5 minus 2 and 3. Okay. So you see the step here, so nice, it's only numbers. So when you do the multiplication, when you do the cross multiply, you multiply, I don't know how we can describe this one, but the diagonal, I mean, both of them, they will be diagonal, but multiply 3 times 8, and then you subtract the other cross multiplication, so minus 2 minus 5. Okay, don't forget to put bracket here, because otherwise you don't know what's the multiplication of the minuses. Okay, so it will be 24, then we have a minus, you have 3 minuses, so minus times minus is a plus, times minus is a minus. Minus 5, 10 minus 10. Okay, so that would be 14. Can you box this one, because this is, you will use it, and then move to delta 1. So delta 1, what you need to do, you use this is called the determinant, but you need to replace the first row with the right hand side of equation 1 and equation 2, which is negative 60, 36, and then you put the second column. Okay, again, you do the cross multiply, so it will be 3 times negative 60 minus 36 times negative 5. Okay, it will be negative 180. And then we have minus times minus is a plus. So 6 times 5 is a 30, and 15 plus 3 is 180. This one will be 0. Is it a 0? Okay, yeah, it's a 0. Okay, delta 2 would be, let's see where I need a space here. So delta 2 would be, we keep the first column, 8 minus 2, and replace. So always here, here's how you understand why we replace column number 2. So delta 1, we replace column number 1. Delta 2, we replace column 2 by the right-hand side of the two equations. So that will be negative 60 and 36. Okay, so again, so it will be 8 times 36 minus, again, so don't forget the minus, the first minus. And then we have minus 2 and minus 60. I hope that we don't do mistake in the first solution here, because you see that one of the answer will be 0. Maybe V2 will be 0 or V1. Okay, so let me erase the, okay, so let's put delta 2 here. We box it. And see, I don't need this anymore. This is for delta 1. Okay, so delta 2 will be, this will be 8 times 6 is 64. And then 24 plus 4 is 20, was it? 27. 286, I think. Then we have minus times minus is a plus, times minus is a minus 120. Okay, so again, I mean, you look down here, you could double check. Easy. 3 times 60 plus, I mean, minus, well, sorry, this one. Yeah, I mean, you could check, as I said, if you want to check your steps for delta 1 and delta 2, it's already clear over there, and it's nice and easy to review and check your. So whatever that number is, and then the solution will be for V1 will be delta 1 over delta, V2 will be delta 2 over delta. Okay, so if we erase, so V1 will be delta 1 over delta, and V2 will be delta 2 over delta. Well, it's up to you, whatever method you use, elimination, substitution, or the matrix. Okay, and any other question since we start with the assignment 14? Any other question in the 14? You need me to go over it? Okay, and this one, any question on this one? This is again, just label I1, I2, I3. How many nodes do we have here?
1, 2. Sorry, 2.
Which, I mean, on the top, how many we have on the top?
1.
You sure? Well, I count them 1, 2, 3, 4, 5.
Isn't this the top one whole one?
Yes. The reason that I did this here, because sometimes students, they think that these are different nodes. So they give V1, V2, V3, V4, V5. If you do that, whatever you do, you spend an hour, 2 hours, you will never solve this problem. So that's why I just pretend that this is a different node. So this is not a node. Each connection here, it's not a node. This is exactly like the one that we use in the breadboard in the lab. So those points here, when you hook the resistors or you hook a voltmeter, you bring the +5 or +15 and the ground point here. That's exactly the same, this one. So these are one complete node, one node. It's not a super node, it's just one node. Okay, so this is the first thing that you need to pay attention to. Okay, and then again, you assign the currents. Okay, there's no wrong of you assign it up, but again, you have to be careful when you write down the I1 or I2. Let's do this here. Okay, let's do I1, I2, I3, and let's assign I4 goes to the top. Okay, so now we need to apply the KCL at node V0, which is this node here. So current leaving that node is I1, I2, I3, and 4. So I1 plus I2 plus I3 plus 4. That's this current here is leaving the node, this one leaving the node, this one leaving the node, this one leaving the node. Now current entering the node will be the 6 is hitting the nodes, going toward the node, so 6, and the I4. That's my assumption, okay? Now we need to write the KCL, I mean the Ohm's law source. So I1 goes from V0 to the ground, which is 0 over 2. So you don't need to put minus 0, as you know, after some practice, you could eliminate or omit the 0, okay? Plus V0 over 4 plus V0 minus 0 over 8, what's it? 1, 2, 3. So which one I assume on the top? I need to, so there's no need for this one. I want to assume one of them goes up. Okay. Just one of them I'm assuming from bottom to top. Okay. So when you come to I3 here, so there's no I4. There's there an I4? No I4. Let me correct myself here. So there's no I3 here. Plus 4. I'm going to correct this one first and then move on. So I1 leaving the node, I2 leaving the node, 4 leaving the node equals to I6 entering the node and I3 entering the node. Okay. So then applying Ohm's law, so V0 over 2 plus V0 over 4 for I2, and then plus 4 equal to 6, plus now I3 is going from 0 minus V0 over 8. Okay, so this is the difference between assuming current from top to bottom or from bottom to top. Both they are, I mean, correct, both directions, whatever you assume. But again, if you don't pay attention to the 0, then what's going to happen? You're going to forget about the 0, and then you're going to forget about the minus. So then you think that I3 will be V0 over 8. Okay, that's why I prefer to assume current goes from the non-reference node to the reference node or to the 0 volt. Okay, so we'll keep this one. So 0 minus V0 is minus. Okay, so both they are giving the same. Now we need to multiply by 8. Okay, so then, so that 8 over 2 is 4, so it will be 4 V0. And then 8 over 4 is 2. 2 times V0 is plus 2. And then I could move the 4 here first, you know, so I don't want to multiply 8 times 4 and then 8 times 6. So this will be redundant. So I could move the 4 to the 6 here. So it will be 2. Okay, so that one. Okay, let me write it down here one more time. V over 2 plus V0 over 4. And then minus V0, I can take it to the other side. And the 4, move it to the right side. So this one goes here. It has a minus, so switch to plus. And that 4 has a plus, switch to minus. So minus 4 plus 6 will be a 2. So we multiply this by 8. So we get this one. So 8 over 2 is 4. Then 8 over 4 is 2. 2 times V0 is 240 here. And then 8 over 8 is 1. So it's B plus V0 equal to 16. Now, since we have only one node, that means we have only one unknown, which is V0. So that will be 7 V0 equal to 60. So 4 plus 2 plus 1. So V0 will be 16 over 7. So again, if I ask you to find what is the current I1, then you go to the original equation, which is V0 over 2. So whatever V0 is 16 over 7 multiplied by 2, this is your current. Okay. If you ask to find what is the power consumed by the 2 ohm resistor, again, you could use V naught square or V0 square over 2. This is one way. Or you could use I1 square times 2. Okay. Because the voltage here across the V2 is V0 minus 0, which is V0. Okay. Any question regarding this problem? No. Good. Okay, let's see here. How about this? Okay. Again, I want you to pay attention here. If this voltage, let's say, same problem here, but I switch the polarity here. Even for the 12. Okay. So this is 5 ohms, 10, 2, 9, and Vx. Okay, same problem, same circuit, but I flip the polarity of the power supply. Same steps, I1, I2, I3. Step number 2, apply KCL. So I1 is entering the node, I2 and I3 are leaving the node. Okay. Step number 3, apply Ohm's law. So now, okay, here now, sorry. I'm using this circuit here. Okay, I'm going to erase this, yes. Okay, so the 12 here is a minus, okay? So you have to say minus 12 minus Vx over 5 equals to I2. So I2 goes from Vx to the ground, which is 0 over 2. Plus I3 goes from Vx minus, okay, and then minus 9. Okay, so here you have to be careful. If the polarity is a minus, so I3 is going to hit the minus, so the voltage is a minus. And you already have a minus from the definition of the current I3 is equal to the voltage here minus the voltage here. Let's call this as V1, for example. So Vx minus V1 over 10. So it's just over 10. So what is V1? V1 is equal minus 9. Okay, when you flip the polarity, then the voltage it becomes a minus. Same thing for the voltage here. So you could call this as V2, for example. So say V2 minus Vx. Okay, if we call this is V1, this is V2, so we say I1 will be V2 minus Vx over 5. Now what is V2? V2 equals to minus 12 because we flip the polarity. The voltage here is V is 12, it's a plus because here's a plus here, here's a minus. Okay, so that's the things that you might need to pay attention in the exam if I brought one like this. Okay, now again, it will be only one unknown, so there's no one equation actually. Okay, so you need to multiply everything by, so pay attention to the minus sign here and the minus sign here. So it will be minus, if you multiply this by 10, so 10 over 5, it will be 2, so it will be 2 times negative 12, it will be minus 24, and then minus 2Vx equals 2Vx equal, this is 10 over 2, would be 5 Vx. Can so multiply, you know, this term by 10, so 10 over 2 is 5 times Vx, 5 Vx, and then we come to the to this term here, it will be a plus Vx, because 10 divided by 10 is 1, and then we have a minus times a minus, so it will be a plus 9. Okay, so we need to bring all the x's in one side and all the numbers on the other side. So we have 5x, 1x, this is 6, minus 2, so this is will be 4Vx, and then take the 24, negative 24 to other side, so it will be 24 plus 9. So Vx will be 33 over. Okay. So this is again if we change the polarity, either both of them or since we change the polarity in both of them, then the answer would be the same. If we don't change it, like in this example here on this homework problem, then it will be I1 will be 12 minus Vx, and then I2 or I3 will be Vx minus 9, not minus 9, not minus 9. Okay. Is this clear, guys?
Yeah.
Okay, good. Let me see here, have any other? Okay, again, this one. Okay, without even thinking, guys, just use the rules. Left to right, up to down. Left to right, up to down. Left to right, up down. Whatever you call it, I1, I2, I3. I want to see this in the exam, or do not write down the equation unless you put those are the guide, okay, for writing the KCL and finding the right solution. Okay, node number 1, I1 is getting in, I2 is leaving, I3 is leaving. Then apply Ohm's law. I1 goes from the 12. Again, why we start with the 12? Because it's a positive. If it's a negative, then it will be negative 12 minus V1 over 8 equals I2 goes from V1 to the ground, so we don't need to write down the 0, over 10 plus I3 goes from V1 where to V2. Okay, you have to finish. You have to see where is the arrow hits. Okay, the arrow hits the V2. So then I go from here to there, so I have to take the difference potential between V1 and V2. Okay, and divide by 4. Okay, and you need to multiply probably by, I think it's 40 here. Okay. Okay, so this will be your equation 1. Equation 2, we go to node number 2, we apply KCL, so it will be I3 equals I4 plus I5. As I said, some people sometimes they like to assume all current direction to the node. But again, my fear is that if you assume it this way and you forgot to start with the 0, that will lead you to the wrong answer. So that's why I prefer, left to right and up to down. Okay, in I3, we have V1. Again, you could write down all the currents before you start applying, the KCL. I1 is 12 minus V1 over 8. I2 is V1 over 10. I3 is equal V1 minus V2 over 4. I4 is equal V2 over 1. And I5 will be V2 minus 24. Or you could use it in the equation directly. So I3 will be V1 minus V2 over 4. And I4 will be V2 minus 0. Okay, sometimes I put the 0 just to remind you that that is a 0 when we apply the rules, plus V2 minus 24. Again, if the polarity was flipped, then it will be minus minus. Minus times 1 will be a plus 24. Okay, multiply by 4 and then simplify the problem, put the all the V1 in one side, V2, and then the right hand side is the numbers. And then use one of those techniques to find V1, V2. One of the techniques to solve the two equations. Okay, any question? So again, it's just a matter of following those few steps. Okay, and the more you do, don't say that I'm wasting my time and why do I need all of this? No, do it. Okay, and the more you do it, the more you relax when the filing comes or when the exam comes. Okay, when you do the homework, take your time, step by step. Have a cup of tea as mine here, or a cup of water, not anything else. Okay, and relax and enjoy the math and enjoy the KCL and Ohm's law. Okay, is this the last one here? Oh, there's more. That's the last one. Okay, what do you think? Easy, hard?
Need to practice.
Exactly, practice. So if you don't practice in anything, it's hard to learn. Okay, so need a practice. Good. So okay, what do you need me to go? To go to chapter 7 or go to chapter 13? This is chapter 13.
Can we go back to chapter 6? But it's actually in the book though.
Yeah.
Practice problem 6.7.
You mean homework number 7?
No, it's in the book. It's practice. It's a practice problem in the book.
Oh, practice.
6.7.
Can you share it with us?
Let me see. Someone else can go while I try to figure out how to share.
I have to give you a permission. So go to the green arrow, and I should give you the permission first. Let me see. Okay, share. do you have it on your screen? Or can you draw it on your, if you go to your screen, there is a whiteboard. So if you go and hit
I'm gonna see
share.
if I can download it because I'm not on my iPad actually.
Oh, okay. So okay.
I took a picture of it already anyways. I'm just trying to figure out how to put it in the chat.
So when you go and you share, there is something called whiteboard. You click on that one and hit share, and then the whiteboard will show up, and then you can draw the circuit, you know.
Okay.
Just like this here. I don't have the book with me now, but so let's go back to, oops, sorry. So while you're doing this, I'm going to go over, let me see here, what that, okay. How is about the mesh? Are you comfortable with the mesh here?
Can we go over one of them?
Yeah.
Either one of those.
Okay, let's go over number 12 here. Number 12. Okay. Again, a mesh, which means KVL, which means voltages. So when we see voltages anywhere, we should be happy. Shouldn't be upset. Okay, should be panic. If we see current, sometimes you need to be a little bit upset. Okay, why? If that current is being located between two meshes, like here. Okay, so that's when you need to use what we call the super mesh. But if the current is on the side, it's in here or somewhere here or somewhere here, actually you should be happy. Why? Because that current will solve one of the mesh currents. So we'll see here, assuming currents here, I1, I2, and I3. Okay, before I move on and apply KVL, he said asking for finding IX. I put IX in the side here, and IX is the current flowing here, which means is the difference between I2 minus I3. Okay, and why I start with the I2? Because IX, it has the same direction as I2. Now, let's ask one more question. Let's say put here, let's call it, this is IN. Okay, IN goes, okay, on the top. So what's IN? It will be I2 minus I1. Why I start with the I2? Because IN, I assume it in the same direction as I2. Okay, so that's why so in other words, that to solve for IX, I need to find I2 and I need to find I3. Now, to do that, I need to use the mesh analysis. To do the mesh analysis, I need to assume, you know, the meshes. Okay, those are the three meshes. Meshes is a complete path. Okay, they don't intersect with any other mesh or loop. So this is a loop here. Again, we don't need that. We only label the meshes. So again, when you see current here, you should celebrate here. Say, okay, now I1 is equal to 3. Okay, good. That's one of the mesh currents. And then come to the loop number 2. Again, follow the rules. If we want to use the inspection, we have 4. Let's move this here. You don't need it. Just, okay. We have I2. So we have I2 and I1 and I3, and we have equal sign. Okay. Remember the inspection, we write down all the variables, I1, I2. Now, I2 is, we have to use all the resistors here. We add them up. So it would be 9, would be 19. And it will take the plus sign. And then we come to the contribution. I1 contributing with 5, so minus 5. And then I2 contributing, I3 contributes with I2 by 10. So it will be negative 10. Okay, in the equal signs, we have a negative 20 plus 12. That's negative 8. So take it to the other side, it will be 8. Again, this is by inspection. If you wish to do that, it's fine. If you want, say, no, I'm not comfortable now to use this technique here. So let me use my technique. My technique will be 5I2 plus 4I2 plus 12 plus 10I2. Now I'm just using I2 because this is my working loop. Can I work on loop number 2 now? So everything related to loop number 2, the volts drops will be a positive. And then negative, so we're done with I2 times 10, and then negative 20 equals to 0. Okay, collect all the similar terms. So I2 for I2, 5 is 9, 10, so it will be 19, I2. And now we need to see the contribution. Okay, so it will be for the neighboring contribution of I1 will be negative 5I1. I should put it over there anyway. And then negative contribution of loop number 3 contributed to loop number 2 by 10I3. And then, so let me, oops, slow batteries here. Okay, let me finish the first equation here, and then we go to the second one because I didn't finish that yet. I'm going to put the minus a little bit to the left here. So again, 5I1, I2 for I2 plus 12 plus 10 I2 minus 20. And then the contribution will be minus 5 I1. And contribution of I3 will be minus 10 I3. That's equal to 0. Okay, so now I collect again the 19, and the I2, and the I3 is there, minus 5 I1 equals to, so here's negative 20 plus 12 is negative 8, take to the other side is 8. Now let's rearrange the equation, minus 5 I1 plus 19 I2 minus 10 I3 equals to 8. Now I1 is given or determined, which is 3 amps. So I can plug for I1 plus 19 I2 minus 10 I3 equals to 8. So negative 15 move to the other side, it become a plus. So it will be 19 I2 negative 10 I3 equals to 15 is 23. You box it and give it a number. Okay. And then we move to loop number 3. So his I3 will be 10. So everything will be a plus, okay, for a loop number 3. So when you work on a particular loop, whatever that loop is, you call it I3, I4, whatever, it has to take all the positive voltage drops. So 10 and then plus 24. Okay, so again we hit the plus, and then plus 10 I3. Okay, you're done with the I3. Now we look to the neighbor. What do we have? We have a negative 10 I2. I1 is not attached. There's no common resistance with loop number 3, so I1 is not there. Equals to 0. So we have minus 10 I2. Rearrange the equation. Plus we have. Did I put the 6 here? Oh, that would be 6. Sorry. Okay, 6 I3, 10 I3, so it'll be 16 I3 equals to negative 24. Okay, two equations with two unknowns, whatever you want to use, elimination. If you put, always when you solve the problem, try to put them under each other, okay? Especially if you use the elimination. Okay, you cannot have them far away from each other and figure out what is the next step here. Okay, and here might be a little bit different here, but again, if you want to do the elimination, you have to multiply the first equation, the top one, by 10, and the second one by 16, just to make this is 160 and this is 160. Okay, so in order, or you multiply the first equation by 19 if you want to get rid of I2, and you multiply the equation 2 by 10. Just, swap in order to make this is 190 and this is 190. So whatever variable you want to get rid of, if you can't multiply one equation by a number to match, the number in the next equation, like in this case, because in this case there's no matching here. You cannot multiply this by the second equation by a number and leave this first equation to match I3, to match the coefficient of I3. So let me see here, what's this here? Minus 24. It's 23, sorry. So this is minus 10, I3 is 22. Again, I prefer to use delta. Okay, minus 10, 16, 19, negative 10. Okay, solve for delta, cross multiply with the minus sign. Sometimes I just remind myself, what should I do? I multiply negative 10 times negative 10 minus, so I put a minus and I put those two heads errors, means it's a cross multiply. Minus 10 times minus 10, and then minus 19 times 16. And then you do the delta 2, I mean, whatever you want to call it. Yeah, it's called delta 2 and delta 3. So in this case, when you find I2, it has to be delta 2 over. So just match the symbol. And delta 2 will be, again, we'll put the right-hand side first. Okay, and then 16, negative 10. And do the same thing for delta 3. So the reason I call it delta 2 and delta 3, because I want to match I2 and I3. Okay. So delta 3 will be, I keep the first column here, same. And the second column replaced by the right-hand side, negative 24 and 23. Okay, and then find, I2 will be delta 2 over delta, and I3 will be delta 3 over delta. Again, it's up to you, whatever method you use, that's fine. But again, I mean, as you see here, it's very clear, minus 24 multiplied by negative 10. Okay, and if you make it clear with the parentheses, with the minuses, and then the minus, and then 23 multiplied by 16. So put everything in a practice, in a bracket. Okay, and then if you try to review or to check your results, you could go easy and find out if you do any wrong. Okay, guys, are you okay with this one? Any other problem you want to look at it? I mean, I could stay with you as the election last night to 12 o'clock. You want to stay at that time? Or you're going to sleep? Okay, so let me see here. Let me clear this. Okay, is this one fine? Easy? Okay, again.
Can you do that one, please?
Okay, here we go. Is this step clear?
Yes, sir.
Good. I1, I2, I3, I4. So I want you to close your eyes and mark this one, okay? Just, become like drinking water. You don't need to think about it. First thing you do, sign current direction. Oh, wait a minute. Sorry. We are not doing the nodal analysis. We're doing the mesh analysis. By the way, this could be solved by both. By nodal analysis, if you assume these are the two nodes, V1 and V2, and apply KCL. Okay, how about that? Let's do this one. Let's use the nodal analysis just to show you how to write down the two equations. Use nodal analysis, okay, to solve for V1 and V2, or to solve for the current through 1 ohm resistor. Okay, so if you apply KCL at V1, current leaving the node I1, current leaving the node I2, current leaving the node 5 equals to 0. And all the currents is leaving the node, leaving this here. This is out, this is out, this is out. Again, apply Ohm's law. I1, where's I1 going from? From here to where? To this point here. And it will go not to the ground, to this voltage here. After that goes to the ground, but before that's going to hit like this one, exactly like this one. So instead of drawing this resistance here like this, they draw this way. Same thing, same as the right hand side, but they draw it in different way. That's it. Okay, so it's V1, I1, so again will be V1 minus 40, because the current goes from here and it's going to hit that voltage 40 before it hits the 0. So you have to use the 40 ohms, 40 volt. Divide by 1 plus I2 going from V1 to V2, divide by 2, and plus 5 equal to 0. Multiply by 2, we get 2V1 minus 80 plus V1 minus V2 plus 10 equals to 0. So everything will be multiplied by 2. Then move to node number 2. So I1 is coming in, sorry, I2. 5 is coming in, I3 is leaving, so equal. I4 leaving the node. Now apply Ohm's law. So I2 goes from V1 to V2 over 2 plus 5. And then I3 goes from V2 to 0. So V2 minus 0 over 4. And V2 and I4 will go from V2 minus, look here, we have a minus. Remember I told you in the previous example that if the polarity is minus, then you have two minuses here. The minus from the law, when you say apply Ohm's law, we said V1 or V2 minus, okay, or minus the voltage that the current goes through, and then the minus of the voltage itself. Okay, and then multiply by 4, so it will be 2V1 minus 2V2 plus 20 equals to 4 times equal to V2, so we'll cancel on the 4 plus 4V2, because we multiply everything by 4. Okay, so 4 over 4 will be V2, 4 times V2 is 4V2, and then plus 20 times 4 is a plus 8. Okay, you need just to move the variable to one side, so you move all of this here down here, collect the similar terms, and then move the 20 to the right hand side. So it'll be 80 minus 20. Okay, so then you establish the two equations, and then you solve for I1 and I2 and I3, or after you find V1 and V2. And if you ask to find the power, you know the current, I squared times resistance 1, you get the power consumed by 1 ohm resistor. You want to find the power consumed by the 2 ohms, it will be V1 minus V2 or I2 squared times 2, and so on. Okay, let's move to the mesh analysis. Okay. Anybody needs this? Okay, mesh analysis. So here's loop number 1, whatever you call it. You call this is 1, this is 2, and this is 3. Okay, let's start with the easiest one, I3 equal what? 5. Okay, square this, put it somewhere here. Okay, now apply KVL. Okay, you want to do the inspection method. We have I1, I2, I3 equals 2. Okay, the number after the equal, it will be the opposite sign of the 40. So 40 will be a negative, so when you take it to the right, will be a plus. Okay, now our working mesh is I1, so everything, all the coefficient of I1 must be added, the resistance must be added, and they must have the positive number. So we have, let me see what's in here, 2 here. I covered with. Okay, we have 2 plus 4, 6 plus 1 is 7. So this will be 7. And again, it will be a plus. Now, contribution of I3 will be negative 2. Contribution of I2 will be negative 4. Okay, and you're done. This is your equation. Again, if you don't feel comfortable using this one, use the regular method. I1 times 1 plus I1 times 2 plus I1 times 4. Then you end up having 7. And then contribution of I3, contribution of I2 will be I3 times 2, negative 4 times I2, negative. Okay, this is your, well, before we box it, let us get rid of I3. So I substitute for I3 is equal 5. So it will be 7I1 minus 4I2 minus 2 times 5. That's equal to 40. So 7I1 minus 4I2. Take the 10 to the other, the 10 to the other side. So it will become a plus. 10 plus 40 is a 50. Okay, now you box it. Okay, and call it equation number 1. Okay, move to mesh 2. Okay, mesh 2. Mesh 2. Okay, our working loop is I2. Our working coefficient is I2. So I2 will take all the sum of all resistance with the plus sign. And the right hand side will be 20, because originally it's a minus, because I2 hits the minus. Take it to the other side, become a plus. Now, I2 will add the resistor, so it will be 12. We'll take a plus, and then I1 contributes with a negative 4, and I3 will contribute with nothing, correct? There's no contribution of I3 to, so this will be 0. Okay, so it will be minus 4I1 plus 12I2 equal to 20. Okay, good deal. I1, we need to solve the two equations, so let's put them down here underneath each other. Okay, so now I could use the elimination by multiplying equation 1 by 3. So 3 times 4 is 12, and then add it to equation number 2. So if I do that, if I multiply equation 1 by 3, so we'll get 21 I1 minus 12 I2 equal to 150. And then add these two here. Okay, so 4 plus 21 is 24 I1 plus 12 negative 12. They go away. 20 plus 150, 170. Then, so this is I1. Okay, and then I1 would be 170 over 24. Use one of those equations, 1 or 2, to plug for I1. You prefer the matrix, you can do that matrix. Okay, you want to check your result with the matrix solution, you could do that. Okay, guys, so what do you think now? Material start to be clicking in?
Yeah.
Good, good. So again, more practice. Do not regret it, I believe. And you will enjoy it. Especially you have your iPad, you could copy or scan the homework problems or the problems in your iPad, and then you could enjoy it, Okay. Now, what's the time now? So almost now, hour and a half. You need more? So what else you think that you need a little bit more drilling or practice? Let me see here.
I think I'm okay.
Okay, how about this? You like this one? Where's my pen here?
Yeah,
You-
I'm very comfortable with this topic.
You are comfortable with this?
Yeah.
Okay. Anybody wants me to go over it? You know. So basically just combine these two here. And what do you think the value for this resistor is?
24.
Well, no.
Sorry, 12, 12.
12, okay, good. So it will be the equal method. So basically your circuit will be, I mean, this book here, I got this from another source. This book, they like the conventional theory of the current flow. They believe that the current coming from the negative. So that's why they flip the polarity of the battery, you know. So, but the current direction has to be. So as I said, so you could draw this way. That's what they call the conventional direction of the current. Current that comes out from the positive polarity of the supply, but in reality, the current actually coming from the negative. But again, it doesn't matter which current, you know, same power, same voltage drop will produce whether the current going this way or current going the other way. Same thing. Okay, so so we have 36 here, and we have 12, and we have 6. So the current here, or whatever direction you want to pick, it will be, so IT will be 36 over 12. And this I is going to split. So that voltage, what's the voltage here? 3. Is it 3? Yeah, 6, 18, sorry. So that would be 2. So now this current, again, you know, by logic, you know, current 2 amps, resistance are equal, so it has to split equally. So there's 1 amps here and 1 amps here. You want to use the rules, okay, we need to find I1, so it will be IT, which is 2, multiplied by, if this is I1 here, or IR, what do they call it, IR3, this is IR2, so it's IR2. Total current entering, we multiply by the opposite resistor over the sum of the resistors will be 1. Okay, and then the second one also will be 2 times 12 over 20. Okay, and you need to find the voltage drop here. You have the I, which is 2 multiplied by the 6, so this will be 12, and this is 2 amps, same current flow. This is, so you have current 1, 24, so it will be 24. So apply Ohm's law here, apply Ohm's law to find. Okay, so if you feel comfortable with this type of series parallel problem, fine, unless you, again, this one you need to combine the two resistors. You have 20, so it will be 10, this is the equivalent. Here's will be 5, 10 over 2. Again, you could use 1 over 10. If you want to waste your time, that's fine. If you want to make it quicker, a little bit quicker, it would be 10 times 10 over 20. And if you make it fastest, it will be 10 over 2. So there's 3 methods to use to determine the R equivalent of the two resistors or the equal sign resistor. Same thing is 20 over 2, it will be 10, and here's 10 over 2, it will be 5. So it'll be, this is 5. So again, the actual circuit will be, if this is 10, this is 5, and the voltage here is given 12. So I would be, whatever IT would be 12 over 15. Okay, because you have this is ET, and this is total resistance, 15. So IT, and then again, I will split, okay, whatever that current will split same by 2. because they're equal resistor. To find the voltage here, you multiply I times this I times the resistance. So it's similar to this one, but we have two parallel branches. Okay. Okay, any other question, guys? I mean, I could stay with you until the dawn, until the sunrise. So go to here. Okay, are you familiar with, I mean, with this here, KCL? I mean, we use this a lot, so suppose this would be a piece of cake here for you. Now, maybe at the beginning was hard, but now I think it's easy. So for find 5,9, you just, this is one node, so current entering the node is 10. Current, I couldn't see this very well. Entering the node is 3 also, 3 milliamps. And current leaving the node is 8 milliamps and the I. Okay, just simple equation. Move the 8, be 13 minus 8 equals to I. Okay. This one, same thing, even 5,9. Is this 5,9 or 5? Oh, this is 5,10. So. Wait a minute. 2. I think I mixed the two problems. I looked to the 5,9, then I looked to the 5,10. So let me clear this one and do the 9. So current entering the node. So again, this is one node. So current entering here, current leaving. So it will be 10 equal to 2 plus I. Find the current through the resistance R. Okay, and then this one would be current entering the node. Again, this is a node, one node. So current hits, current leaving, current goes in, current leaving. Okay, and entering the node is 2 milliamps. Current leaving plus, what's that here? I cover this with my, oops. Okay, this is a 3, 2. 2 plus 3 equal 8 plus I. Okay, 2 is entering, 8 is leaving, 3 is entering, I is leaving. Okay, guys, any other question? Maybe do you know how to find this here? Determine the current through the resistance, through all resistors. So you have to combine all of this, and then I will be the voltage 16 over R equivalent. Okay, and this one here. So you have to combine this first, and then combine these two second. So it'll be this one and this one and this one. Okay, so you combine 1 and 2. So it'll be 3, 2 over 3, 2/3. And then you combine the 5 and the 6. So 5 times 6 over 11. Then you have the 3 here. So these two becomes in series. Then they become with the 3 in parallel. Okay. So again, Always look to the circuit, doesn't matter how it's complicated. Oh, sorry, I forgot this resistor here. Okay, so all this will be combined, the four. So this 3 here. And with this would be in parallel, both of them. After you combine those 3 in series, you combine it, the result combined with the 3 all in parallel. Okay. This is again. This is again. Again, this is will be. I think we did this one time in the class. Okay, guys, you want to go sleep? Still early. If you don't have any question, it's fine to to leave. But if you do have questions, just let me know.
Okay, Professor, I'm all set.
Okay, so I think most of the people. Okay,
Yeah. Bye.
see you then, guys.
Thank you.
Thank you. Have a good evening.
You too.